Welcome to video. Myself Mr. D.K. Lakhe, working as a lecturer in Electrical Engineering Department. So in this video we're going to learn about the information about soft starters and their use in the energy conservation. So after completion of this topic, student will be able to understand the suggest relevant energy conservation equipment for the given electrical machines with justifications and understand the working principle and application of soft starter. So here in this picture we are going to say the single line diagram of soft starters. So we say that the KM1 is nothing but the main contactor, FR1 is the overload relay, and Q1 is our soft starter. So then after M is nothing but our the motor. So soft starter is an electronic starter designed to accelerate, deaccelerate three-phase induction motor and to control the voltage applied on the motor during start and stop. So soft starter continuously control the three-phase motor's voltage supply during the startup phase. This way the motor is adjusted to the machine's load behavior. So mechanical operating equipment is the accelerated smoothly. So starting of induction motor, we know that for the induction motor, starting torque is approximately proportional to the square of the current drawn from the line. So the starting current is proportional to the applied voltage. Indirectly we say that the torque can be also considered to be approximately proportional to the applied voltage. So an induction motor will develop far too much torque when connected directly to the supply. So we say that at the instant of startup there are some unnecessarily electrical and mechanical components are to be present. So we say that these are some effects. These are unnecessary mechanical effects. Sudden impact at the startup on the load followed by the rapid accelerations to the full speed causes the excessive wear and tear which on the belt and pulleys, gears and chain, coupling and bearing, cavitations in pump. So unnecessary electrical effects, we are going to observe that the heavy current surge on the electrical supply which can be severe enough to cause the voltage dip and flickering of light, then burning of contact due to the high current which are many times the motor of full load current. Due to this, the problem arises by these effects are continuous maintenance is required, greater chance of the unscheduled shutdown, oversized mechanical and electrical components to cater for the power surge on startup, and the short component life. Then the solution of the problems are soft starters. Okay, so by adjusting the voltage during the starting, the current drawn by the motor and the torque produced by the motor can be reduced and controlled. So here we are going to see the block diagram for the soft starter. So here we are going to observe that three-phase supply is available. So here we say that the maroon color shows the power signals and the violet color shows the control signals. So here we are going to use the protective devices. Then we have the thyristor block, firing pulse block is there, and microcontroller units is there. So whatever is the signal received from this induction motor will to be connected to the microcontroller, and as per the signal received, this microcontroller will use command to the firing angle or firing pulse generator, and then after this thyristor are going to be operated. So this is the basic block diagram for these soft starters. So starting principle of starters, soft starters are, let us consider we have by using 6 SCRs in back-to-back configuration as shown in this figure. Okay, so soft starter is available to regulate the voltage applied to the motor during starting from 0 volt up to the line voltage. So the feedback from the motor to the logic circuit used in the control of the SCR firing for the stabilizations of the motor acceleration. Okay, so keep in mind the frequency do not change as in VFDs, only the voltage and current are to be changes in soft starter. So these are the characteristics of soft starters. We are going to observe that this is the speed versus torque characteristics, and this characteristics is the current versus speed characteristics, okay, for the soft start. So here in the green color we are going to observe the characteristics for the DOL, that is the direct on load starter, and violet color shows for the soft starting or soft starter. So here we are going to observe the load torque. Similarly here we can say that with the help of this DOL, directly current is rapidly increased, while by using this soft starters we can say that the current is reduced. So smooth starting is achieved by using this soft starter. So features of soft starters are like this: the soft start and stop is achieved, then pulse or kick start is achieved, then current control ramps, pump characteristics, tacho or encoder feedbacks is available, dual adjustment, that is start and stop characteristics for the varying of the load is achieved. So soft starting features are nothing but see here one characteristic is shown. This is the characteristic of voltage against the time. So we say that similarly here the current speed characteristics for the soft starter. So by adjusting the initial voltage from 10% to 15% of rated value, adjusting the ramp time from the 1 to 30 seconds can be extended. So this is the benefit by using this soft starting. Means for this short duration we can accelerate that motor in a smooth step. Here we are going to compare the soft starters with DOL and star delta starter. So we know that for the starting of this soft starter, 10 to 15% of rated voltage, ramp voltage of is applied up to the, and we say that suppose consider DOL starter. So direct online starter, we say that the whatever is the voltage is available directly applied to the terminals, means rated voltage 100% voltage is applied. Here in the star delta starter we say that 58% of rated value is applied, while in the soft starter we say that the ramp up of the ramp up of adjustable, means from 10% to 50% of their value is to be achieved in the smooth way. So these are the some advantages of soft starters. It eliminates the high inrush current and high mechanical torque on startup, then reduction in the cable and switchgear rating of the power supply network, limits the line voltage dip, soft stepless acceleration and deacceleration is achieved, then kick start function for the heavy duty and functional load with high starting torque, then current limiting characteristics are achieved, then bypass contactor increases energy saving and avoid current and torque peak, put less electrical stress on the power supply network and mechanical stress on the entire drive, again reduce the stress on the coupling and other transmission devices like gearbox, shaft and belt. So these are some application of soft starters where we can use vacuum pumps are there, pulverizers are there, mixers, compressors, then conveyors are there, propeller fans are there. So all these are and many more other applications have been obtained by using this soft starter. So I have taken the information from these references. So thank you for watching this video, and if you have any doubt regarding these soft starters, you comment in the chat box. So thank you for watching.